morning, chemistry enthusiasts! Here we are again, the PS1Y1 Chemistry 101. Today, we will indulge in new learning in chemistry. Come and join us!
Oh, hello viewers! Today, we are going to discuss about limiting and excess reactants. Also, we can tackle about theoretical yield. But, did you know that this topic is under a branch of chemistry, which is stoichiometry? This deals on the study of mass relations in chemistry.
Yes, that's it. Little more information what are reactants are. Reactants are all substances that undergo change in chemical reactions.
Now, let's begin this demo. But first, do you know what is limiting reactant? Limiting reactants, these are the reactants who limits the upcoming product in a chemical reaction. We have here two examples of non-chemistry. We have here two bonds and one fatty. Suppose we're going to make two burgers, but we only have one patty, our limiting reactant. Here, so one patty and one bun is equal to one burger. We only have now one burger. It's because we only have one limiting reactant.
Exist reactants. These are the reactants that was not being used during a reaction. The same example with limiting. Suppose we're going to make two burgers, then we have only two buns and one patty. Our exist here is a bun because there is one bun that is not being occupied by the patty. I'm going to put this patty on one of these buns. And here, I have one burger. So this one bun is our exist reactants because it was not never been used for it only have one limiting reactant.
Suppose we have this problem. A fuel mixture used in the early days of rocketry is composed of two liquids. First, hydrazine or N2H4 and dinitrogen tetraoxide or N2O4, which ignite on contact to form nitrogen gas and water vapor. The question is, how many grams of nitrogen gas form when 1.00 times 10 raised to the power of 2 grams N2H4 and 2.00 times 10 raised to the power of 2 grams N2O4 are mixed?
Hydrazine or N2H4 is equal to 1.00 times 10 to the power of 2 grams and dinitrogen tetraoxide or N2O4 is equal to 2.00 times 10 to the power of 2 grams. Question: how many grams of nitrogen form when these are mixed?
This will be our plan. As always, we first need to write the balance equation. The fact that the amounts of two reactants are given tells us that this is a limiting reactant problem. To determine which reactant is limiting, we calculate the mass of N2 formed from each reactant, assuming an excess of the other. We convert the mass of each reactant to number of moles and use the appropriate molar ratio to find the number of moles of N2 in each forms. Whichever yield less N2 will be the limiting reactant. Then, we convert this lower number of moles of N2 to mass.
First off, we'll be writing the balance equation. This is our original equation. N2H4 or hydrazine ignited with dinitrogen tetraoxide or N2O4 to form nitrogen gas and water vapor. The first thing we do is making a table dividing the reactant side from the product side. Then, multiplying them by a number that will make them equal. Write first the atoms of the elements in the reactant side. Nitrogen in the first compound has 2 atoms. In the second compound, we have 2 atoms again. While oxygen has 4 atoms in the second compound. While hydrogen has also 4 atoms in the first compound. On the product side, nitrogen has only 2 atoms. Oxygen has 1 and hydrogen has 2. As you can see, the equation is not balanced. So, we will multiply them by a number that will make them equal. First, we will multiply H2O by 4, making oxygen 4 and hydrogen 8. So, our oxygen in the reactant side and oxygen in the product side is now equal, while hydrogen in the product side is not equal from that of the reactant side. So, we will multiply N2H4 by 2, making hydrogen 8 in the reactant side. Hence, hydrogen from the reactant side and hydrogen from the product side is now equal. The problem is our nitrogen in the product side and that of the reactant side. So we will multiply nitrogen in the product side by 3, making this 6. Now, our equation is balanced. After the solve process, we have now come up with our balanced equation. 2N2H4 plus N2O4 is equal to 3N2 plus 4H2O.
Second step will be finding the moles of N2 from the moles of N2H4 or hydrazine if hydrazine is limiting. First, we need to get the moles of N2H4 or the hydrazine. It is equal to 1 times 10 to the power of 2 grams of N2H4 times 1 mole of hydrazine over 35.05 grams of hydrazine. Then here, the grams of hydrazine will be cancelled. Remain only the 3.12 mole of N2H4. And to get the mole of N2 from hydrazine, we need to multiply 3.12 mole of hydrazine by 3 mole of N2 over 2 mole of hydrazine. Mole of hydrazine will be cancelled and the remaining only will be 4.68 mole of N2. We will be finding the moles of N2 from the moles of N2O4 or the dinitrogen tetraoxide if dinitrogen tetraoxide is limiting. First to do is to find the moles of dinitrogen tetraoxide by multiplying 2 times 10 to the power of 2 grams of dinitrogen tetraoxide by 1 mole of dinitrogen tetraoxide by 92.2 grams of dinitrogen tetraoxide. These grams of nitrogen tetraoxide will be cancelled and 2.17 moles of N2O4 or dinitrogen tetraoxide will be the answer. And to find the moles of N2, we need to multiply 2.17 moles of dinitrogen tetraoxide by 3 moles of N2 over 1 mole of dinitrogen tetraoxide. Mole of dinitrogen tetraoxide will be cancelled and the answer will be 6.51 mole of N2. Thus, N2H4 or the hydrazine is the limiting reactant because it yields fewer moles of N2. As we can see, step will be converting the moles of N2 to grams. Mass will be in grams of N2. It will be 4.68 mole of N2 multiplied by 28.02 grams of N2 over 1 mole of N2. This mole of N2 will be cancelled and the answer will be 131 grams of N2.
Approach to determine the excess and limiting reactant. 2 moles of hydrazine react with 1 mole of dinitrogen tetraoxide. The moles of dinitrogen tetraoxide needed to react with the given hydrazine or moles of dinitrogen tetraoxide needed is equal to 3.12 mole of hydrazine times 1 mole of dinitrogen tetraoxide over 2 mole of hydrazine. The mole of hydrazine and the mole of hydrazine here will be cancelled. moles of hydrazine needed to react with a given dinitrogen tetraoxide. Moles of hydrazine needed is equal to 2.17 mole of dinitrogen tetraoxide times 2 mole of hydrazine over 1 mole of dinitrogen tetraoxide. The mole of dinitrogen tetraoxide here will be cancelled and it will equal to 4.34 mole of
Given 2.17 moles of dinitrogen tetraoxide more than the amount of dinitrogen tetraoxide, which is 1.56 mole, to react with a given amount of hydrazine. And we are given 3.12 moles of hydrazine less than the amount of hydrazine needed, which is 4.34 moles, to react with the given amount of dinitrogen tetraoxide. Therefore, dinitrogen tetraoxide is the limiting and hydrazine is the excess.
So that was it, guys. We hope that you have learned and found the demo informative and instructive. We are looking forward for another demo that we can perform for you. We also like to acknowledge the help of our teacher, Mrs. Merlin Gonzalez, our classmates, and God for making this demo successful.